Hey everybody, I just wanted to make a quick video just explaining a little bit more on how to use upper level maps in your weather forecasting. And so I want to show you how I would use the upper levels and how they can really be useful. And I know it seems a little bit complicated for right now, but if you just want to form what is called a forecaster's bias, meaning just say you want to just quickly glance over things, you want to just look at the atmosphere in a bigger view and a bigger overall picture, and you kind of just want to see what's going on, the upper levels are great, and it's a lot of information that you can depict just from one weather map. So I want to kind of just dive in a little bit into that today, and we're going to go into more detail about it in the weeks to come. However, I want you to be able to see multiple examples of what I'm talking about. So if you didn't already watch the previous video that I posted in the week 6 content about upper air applied, I definitely want you to watch that video because it discusses troughs and ridges and where areas of convergence and divergence are. And ironically enough, this weather pattern right now is very similar to the example in the video. So without explaining too much to keep this video short, just to kind of jump into things, here what I'm doing is I'm looking at the GFS model and I'm looking at the continental view of the United States. And what I did was I selected the upper air charts, and for right now I just selected 500 millibar temperature, height, and wind. So here what you can see is that here, this is the pressure level at 500 millibars. So this is what the pressure level is at 10,000 feet, more or less, in the atmosphere. And here what we notice is that the most obvious part is here is this giant trough really in the heartland or in the middle part of the country. And then sequentially we have two ridges both on the east coast and on the west coast. So here we have a ridge, here is a trough, and then there is a ridge again. So what does that mean? That means the areas in the ridges, they should experience warmer temperatures and drier weather, both on the west coast and the east coast, and that here in the trough, the areas in the trough, they're going to experience cooler weather and they're going to experience more, or they're going to be more susceptible to areas of low pressure, okay? And here, when you select temperature, height, and wind, what you notice here is that here is all the temperature colors. So you can see, again, this is, at 10,000 feet high up in the atmosphere, so minus 30 degrees Celsius up in the core. So this is some really cold or some really good what we call continental polar air, and we'll discuss that next week when we talk about air masses. But for right now, here you can see that here on the west coast is warmer, same thing on the east coast, and we have cooler weather out in the midland part of the country. Okay, so that's one thing that I can look at. So I already know who's warm, I already know who's cold, and who's experiencing dry weather and who is more susceptible to areas of low pressure, okay? Now, I haven't even changed weather maps yet. Another thing that you can do is you can see where the area of convergence and divergence is. So here, if you remember the video, you always want to look for the trough, and if you cut the trough in half, your area of low pressure should be on the right-hand side, and your area of high pressure should be on the left-hand side, because air has to converge here because it's almost like a bottleneck feature. So air has to converge here, and if it's converging aloft at 10,000 feet, then that means air must be diverging at the surface. And if air is diverging at the surface, that means air is being pushed down onto the surface of the Earth, which means that we have an area of high pressure developing on the left-hand part of the trough, what we call the trough axis. Now on the right-hand side, air is doing the opposite. It's diverging aloft. Well, if it's diverging aloft, that means it's converging at the surface. That means we have an area of relatively low pressure here on the right-hand side, okay? So I already know where my area of high pressure is. I know more or less where my area of low pressure should be, probably right in this area where I'm circling. Again, my high pressure will be somewhere in this area where I'm circling. So you can already see what's going on. You can also see what the wind barbs are doing. Now, if you're interested in just wind in particular, you can go just to the upper air, height, wind, temperature drop-down menu, and you can click 500 millibar, height, and wind if you really wanted to. And so this would, as you move your cursor over, this would just highlight the winds. you can see that this is the core of the jet stream right in through here. So in aviation, a meteorologist in the aviation industry is very crucial to its operations because they know where the jet streams are and they know where turbulence is. And so it's worth the time and the money of airline industries to hire meteorologists to do consulting work for them. I love aviation weather. I think it's super fascinating. And so here, what you notice is that this is the core of the jet, where you have almost what we call a jet streak, or the highest or the most active part of the jet stream is. You can see right over the Great Lakes at 500 millibars, and this isn't even cruising altitude. So this is about 114 knots over the Great Lakes. At 300 millibars, this would be cruising altitude right here. So this would be about 30,000 feet more or less. At 30,000 feet, this wind's cranking. So this is about 140, 150 knots, okay? So very, very fast wind speeds for sure. Very, very fast wind speeds for sure. So here what we notice is that when we have this trough, and if we move it through time, we notice how this trough is going to actually move. So a lot of you like forecasting for Harrisburg, your local area in Pennsylvania. So based on the upper level maps, what do I notice? Is that I notice that this trough here, I'll go back to the colors, it's a little bit more visually appealing. Here, you notice that the trough, right? The trough is actually going to move, all right? So that means, now this is Wednesday, so this is tomorrow, so this is the 12Z timestamp for tomorrow, Wednesday. You can see how we had this trough that has moved through, and now as we go over the next couple of days, you can see this big, or once was this big upper level low, has now gone and retrograded back up into the polar regions. And believe it or not, this is really just a piece of the polar vortex that has started to dip down. 'Tis the season that we start getting colder air in the central part of the country, and we start changing up the weather patterns a lot. So this is actually just a piece of the polar vortex. And the polar vortex is always there. It just hides up way far north during the summertime, and during the wintertime it comes and visits the U.S. every more so than the summer for sure. So here what we notice is that now as we go through, now this is the end of the week, this is Friday here, big old ridge, California is nice and sunny, hot and dry, surprise, surprise. And that here we have another little trough extending all the way from Wisconsin down to about Nebraska area. And then we have another ridge, and we also have what is called the Bermuda High. Here is Bermuda right up and through here. We have a nice Bermuda High that is keeping the East Coast nice and dry. So again, I haven't looked at lower levels yet, but by upper level standards, I can already see what's actually going on. And so here at upper levels, what I can do, here at lower levels, again, here is my area of high pressure. Here is my trough axis. Here is where my area of high pressure is developing. There is that big upper level low that is spinning right around the Great Lakes. And then here is another little area of low pressure right up and through here. This is a 10-10 low. It's very, very weak. It's pretty much just caught up in a frontal boundary. But here, again, this would be your area of low pressure. Similarly, where it was and where you expected it to be on the right-hand side of the trough, okay? So this is where you can tell where your weather pattern should be. So this way you can kind of see now if you're correct in your analysis when you look at 500 millibars and you relate it to the surface. So now as we go towards the end of the week, let's get to Friday, and what do we see? Nice high pressure encompassing pretty much the entire eastern seaboard. And that makes sense, because if we go all the way to Friday at the upper levels, here we had a nice big Bermuda High, so we know that here is a ridge, so we should have high pressure up and through this region. Same thing out for California, big old area of high pressure. You can see how huge this ridge is, okay? And that's exactly what we have, area of high pressure encompassing the whole eastern seaboard, and again, high pressure out towards the west coast. So now as we look at the upper levels again, Here we have another trough. Cut the trough in half. High pressure somewhere up and through here. Here's the trough axis. So I should have low pressure developing somewhere around Tennessee, Kentucky, Ohio, somewhere in that region. And as I move through time, that's exactly what happens. So here is another area of low pressure. You can already see, based on the red and blue dashes, you can already see where the trough is, back up and through here. And so here is another area of low pressure that is developing. And here down in the Gulf of Mexico, it's a little disturbance, probably like I guess you could say it's a little tropical disturbance, but it doesn't look like it materializes into anything. And then, you know, as we go into next week, who really knows what happens? This is all fairy tale land. But that's how you use the upper levels and relate them to the lower levels. And we're going to go into more detail about this in the next couple of weeks. But for right now, I just want to paint just an overall picture on how you can just use this to create a bias, just to show, okay, where is it warmer than normal? Where is it cooler than normal? Who's experiencing dry weather? Who's experiencing areas of low pressure, so on and so forth. So I hope this video was informative and I hoped it helped. And let me know if you have any questions.